complex number question here. We have a complex number minus root 3 plus I. You can just keep in mind this, I squared will always be minus 1 because I is the square root of minus 1. And they want me to write Z in polar form. No problem. I'm going to get out my calculator. Hopefully it comes out nicely. I'm in degrees, so I'm going to get this in degrees. I have my POL button. Oh, sorry, POL. And it's a minus root 3. And then a comma. It's a 1i, so the coordinates are minus root 3, comma, plus 1. Two is my modulus, and this is my argument. So R is 2, and the angle is 150. That is not enough to get me full marks. Polar form is, when I go to my log tables and I can see that, you know, in order to do De Moivre's theorem, I need to be in polar form. So you can turn to that page. You can see that that's your polar form. Sorry, here, not with the N. So it's the R cos 150 plus I sine 150. You could obviously write that in radians as well. Okay. The next bit, use De Moivre's theorem. Okay, so I'll keep this open in front of me. De Moivre's theorem means I need polar form, so Z. So first part is Z in polar form is that. They want me to get Z to the power of 4. Well, if I put anything to the power of 4, I'm just going to get an answer. So if we put Z to the power of 4, I'm just going to put this to the power of 4. And then I could multiply it out by itself 4 times, but I don't want to. So De Moivre's theorem allows me to speed that up, and it says put your power here, here, and here. We end up with 2 by 2, 16. What is the cos of 600 minus a half plus I times the sine of 600 minus root 3 over 2. Multiply that out, clean it up, and you end up with minus 8 minus 8 root 3i. So if you took that number and multiplied it out by itself, or, you know, even if you went back all the way back to here, if you took that number and multiplied it out by itself 4 times, you should end up with that. It's just De Moivre's theorem sped that up for me.